meron tayo ditong LED, RGB. Siya ay transparent. 4 yung kanyang pin. Merong pinakamahaba. Yung pinakamahaba, yan ay cathode. Dahil ito, common cathode. Kaliwa, gitna, then pangatlo, pang-apat. Ano naman ang gagawin dyan? Tetest natin kung siya yung may ilaw. Gagamitan natin ng adjustable power supply. So, mula sa kaliwa, dito, tingnan natin ang voltage. Yung mahaba, siya ay ground. Ground. Uy. Mula sa kaliwa, positive. Adjust natin yung voltage. Yun. .89, 13 milliampere, 24 milliwatt, kulay red. Yung pinakamahaba siya ay cathode. Yung pangatlo, tingnan natin ang kulay. Balik natin sa 0. Ang kulay niya ay green. Okay, green. Sa 10 milliampere, 2.57 volts, 25 milliwatt. Okay, 10 milliampere. Pinakadulo, yung ating ground, common, yung pa rin mahahaba. Yung dulo niya, ang kulay ay, balik natin. .69, 10 milliampere, 26 milliwatt, kulay blue. Yan o, blue. Diba? Balik natin sa red, dito sa dulo. Titimplahin natin 10 milliampere. Sa 10 milliampere, 1.85 volts yung red color. So lahat ng LED 10 milliampere. Magkakaiba yung voltage at saka power consumption. Okay, ito na ang ating bagong circuit. Yun. Yan yung ating RGB LED. Tingnan natin. Meron tayong mga capacitor. May transistor. May resistor. At nakakonekta na yan sa supply. Ay, tutoy! Ano nang nangyari dyan? Testingin na natin itong ating RGB driver. So, itong circuit na ito, yan yung pinaka-driver niya. 3 transistor na may mga kasamang ibang pyesa. Okay? RGB. 4 yung pin niya, di ba? O, tingnan natin yung supply niya. Testingin natin. Okay. Ayan. Yan ang supply niya. Patayin natin ang ilaw. Yung isa pa. Sa pang-ilaw, patayin natin. Okay? Tingnan natin kung anong voltage niya. Kung saan siya gagana. Kung anong voltahe. Sa anong voltage magagana yan? Voltahe. Ay, testingin natin. I-adjust natin itong adjustable power supply. Tingnan natin sa 3.7 volts. Di ba? .7 volts. Ayun Nag-RGB na siya. Nagbi-blink. Ang current niya from 23 to 27 milliampere. Consumption, power consumption 85 to 99 milliwatt. Voltage niya 3.7 volts. O, di ba? O. Pwede siya sa 3.7 volts. Ganyan siya kabagal yung transition ng color. Subukan nating baguhin natin voltage. 5 volts. I-adjust natin sa 5 volts. Volts. 5.01 volts. 5 volts. Ang current niya 33 to 36 milliampere. Power niya 165 to 170, 180. Diba? Anong napansin mo sa kulay ng LED? Diba mabilis siya? Nung taas na natin voltage, bumilis yung blinking ng LED. At lumiwanag yung kulay. Diba? Taasan natin. Gawin natin 9 volts. I-adjust natin sa 9 volts. unti-unti siyang bumibilis ang blinking, yung transition ng kulay. Nine volts, 63 to 64 milliampere at 567 to 577 milliwatt power niya. At bumilis yung kanyang blinking. Bukod sa bumilis yung blinking, lumakas yung liwanag niya. So yan ang blinking niya sa 9 volts. Gawin nating 5 volts ulit. Diba bumabagal? And then 3.7. Good day to everyone and welcome to our English department. So here we have the circuit for our project. This part of the circuit is the driver, the main driver of RGB LED. The RGB LED, common cathode connected to the ground. Consisting of 3 transistor, NPN type, C1815, 3 transistor, 1, 2, 3, 4, 5, 6 resistor and 3 capacitor. Okay, our supply works on 3.7 volts up to 9 volts. Initial state of the circuit, current flows into the R1 4.7K resistor. Then to the base of the transistor, switching on the transistor 1. Also the current flows into the R2, making this transistor to saturate collector to emitter and then to the ground. So transistor 1 is on. Because of the presence of base current. And then the current flows into the because transistor 1 is saturated or act as a close switch, current flows into the collector to emitter and then to the ground. What happened to the capacitor is current flows into R3, then to the capacitor, discharging capacitor. Capacitor will discharge through collector to emitter, then to the ground, producing a negative voltage to the base of the second transistor. What happened to the red LED? It will bypass. So the red LED is off, 0 volts off, but the transistor is on, 1. Since capacitor 1 is discharging, it creates a negative voltage to the base of the transistor. So this transistor is off, 0, off. because NPN type transistor only works on positive voltage, but the negative voltage produced by the capacitor can make this transistor to turn off. If this is turned off, current flows into the R4 for 70 ohms and then charging this capacitor C2. Also, the current divides, or current is divided, making the green LED to turn on. So the current flows into the green LED because this transistor is open and the capacitor is charging. If this is charging, it will make this transistor to turn on. Current flows into the R4, then to the capacitor, then to the base of this transistor. So this is on. And then this R5, it will make the transistor to fully on because it serves as a biasing resistor. If this is on, current flows into the R6, making this transistor to saturate. So current flows into the R6 and then the collector to emitter, saturating this transistor. If this is saturated, so this is closed switch, just like a closed switch one. If this is saturated, this capacitor is discharging from here, discharging from R1 to C3. What happened to the next LED is, since this is discharging, it will not turn on. So this is off. So initial state of the circuit, red LED is off, green on, and blue LED off. If this is discharging, it will create a feedback loop to the input base of the transistor 1, creating a negative voltage across the base of the transistor 1, making this to turn off. So initially it is on, now it is off, 0. So if this is off, current flows into the R2, then to the C1, charging this capacitor. If this is charging, current flows into the base of the next transistor, making this transistor to turn on. So it is now on. If this is off, it will make the LED to turn on because current flows into the capacitor, charging the capacitor, also to the red LED. And then if this is charging, it will make this transistor to turn on. Initially this is off, now it's on. If this is on, current flows into the R4 to the collector to emitter of the output side of transistor to the ground. If this is saturated, this capacitor will discharge through R5, C2, then collector to emitter of this transistor. This is saturated and the capacitor is discharging. There's no current flowing into the green LED, so this is off. If this is off, discharging, it will now turning off this transistor 0. This is off, current flows into the capacitor C3, charging the capacitor again and going back to the base of the transistor 1. The LED is on because this capacitor is charging.